Welcome to the video solution for problem 9 from our first super quiz. In this problem, we're given a list of 3 different vectors and asked to do a little bit of vector arithmetic. So there's actually 4 different problems we'll solve. The first problem, we're just going to do a little bit of addition and subtraction along with some scalar multiplication. This is fairly straightforward, so let's try to write this down. So you have u minus 2v plus 3w. So this is part A. And we can write this down here as 3 comma negative 4 minus twice negative root 3 comma 2 plus thrice 2 comma 0. So the first thing we note is that when you want to multiply a vector by a scalar, you simply scale all of the components. So we'll just multiply each of these components here by 2, and in this one we'll scale each one by 3. So we'll get 3 negative 4 minus negative 2 root 3 comma 4 plus 3 times 2 is 6 comma 0. Okay, and then to add or subtract vectors together, you just add the components, and so we'll end up with 3, well, let's see, we'll have minus 2 root 3, so it'll be plus 2 root 3 plus 6 in the first component, and then negative 4 minus 4 plus 0 in the second component. We can combine if we like, 9 plus 2 root 3 comma negative 8. Okay, so that's how we're going to add vectors and scale them. Okay, what's the next problem? Part B. So you remember we have this special symbol that we use whenever we want a unit vector. So if something is a unit vector, we'll tend to use it to let you know it is a unit vector. But also if we're given a vector which is not normalized, it's not a unit vector, then if we want to write down the vector which is a unit vector in the same direction, we'll put this hat over it to let you know, hey, compute this. Okay, so let's do that in B here. So to get the unit vector in the same direction as u, we need to take u, so there's our vector u, and we need to divide it by its length. Okay, or often we'll write this kind of shorthand like this. Okay, we're really taking a vector and multiplying by a scalar. Of course, this better not be the 0 vector or the length will be 0. But okay, so this is what we want to compute. So first thing we're going to need is the length of the unit vector u. Sorry, not the unit vector, but of the vector u. So this is going to be the square root of, well, we have to take the components and square them. So 3 squared plus negative 4 quantity squared. Okay, 3 squared is 9. Negative 4 squared is 16, 9 and 16 is 25, and the square root of 25 is 5. So the length of the vector u is 5, and therefore we're going to get 1 over 5 times the vector 3, negative 4. Or if we put it together, 3 over 5, comma, negative 4 over 5. And one could go through and check now that this is a unit vector by again computing the length. Okay, what's next? We have C. We need to compute a dot product. So to compute the dot product, there's actually a couple of different ways of doing it. One is very algebraic. One is very geometric. So in this problem, it's going to be very convenient to use the algebraic version. So you recall if we have 2 vectors, and let's say we don't know exactly what their components are, we just maybe give some letters for them. So say our u is equal to, say, a u1 comma a u2, and our v is a v1 comma a v2. Remember, our dot product is going to be the product of u1 and v1 plus the product of u2 and v2. So in our case, we actually know the u1 and the v1 are 3 and negative root 3. So we'll get 3 times negative root 3 plus, and then our u2 and v2 are negative 4 and 2. And so we're going to get, well, it looks like negative 3 root 3 minus 8 as our dot product. Okay, finally, we're asked to compute the angle between vectors v and w. And when we want to get the angle between 2 vectors, then it's going to be handy to use the geometric version. So our geometric version of the dot product is that the dot product is equal to the length of v times the length of w times the cosine of the angle between them. And when there's a lot of vectors floating around, I like to use this notation because now I can read it. Cosine of the angle, right? It's a theta, but I read angle between v and w. Okay, so because I have this angle sitting in here, right, which is what I want the angle between them, I can solve this expression for theta. So we can get everything else in this expression. So for example, what is the dot product of v and w? Well, the dot product of v and w we'll get by multiplying negative root 3 by 2, and then multiplying 2 by 0. And of course, the 2 by 0 doesn't contribute anything. So we'll just have negative 2 root 3 as our dot product. So let's come on down. So this expression is going to be negative 2 times the square root of 3. All right, now we need the length of v. So let's see again. What is our v? Our v is negative root 3 comma 2. So let's do a little side work. So the length of v is the length of negative root 3 comma 2. Okay, so that's going to be the square root of negative root 3 squared plus 2 squared. Okay, negative root 3 squared is 3. 2 squared is 4. 3 plus 4 is 7, so we get the square root of 7. Okay, how about the length of w? Well, w, that was actually a pretty easy vector, right? This is just 2 comma 0, right? If we graph this, 2 comma 0 means, say, if we started from the origin, you're going to head out 2 in the x direction and not up in the y direction. So this is just a vector of length 2. We could go through the whole formula, but it doesn't seem to be worth the time. Okay, so we end up with length of v, which is root 7, times the length of w, which is 2, times the cosine of the angle between v and w. Okay, so we can now divide to solve for the cosine. And if we divide everything here, let's see. The 2 and the 2 will cancel, and I'm going to end up with negative root 3 over root 7 is equal to the cosine of the angle between v and w. And so to get this angle, all we need to do now is take the arc cosine. So the arc cosine of negative, and here I'll simplify this as root 3/7 is equal to the angle between v and w. And just as a way of checking if this makes some sort of sense, when we take the arc cosine of a negative value, that means we should be looking at some angle where the cosine is negative. So we should have something, right, which is over here in the second quadrant in terms of an angle. And we actually know that w, right, we already drew w, went this way. And where is v? So v, remember, was negative root 3 comma 2. So, hey, that could be negative root 3 and a 2. Okay, it doesn't line up. All right, we'll just move it over. Beautiful. Okay, so this actually makes sense as a direction, where v could go. Okay, so this all checks out. Excellent. All right, well, hopefully this is helpful to you. Let me know in the comments. Bye-bye.